All right, so this is section 7.3 and 7.4 in your textbook. And 7.1 and 2 were about simplifying, multiplying, and dividing rational expressions. 7.3 and 7.4 are going to be adding and subtracting those rational expressions, okay? So the first thing that we're going to go over is adding and subtracting with the same denominator, okay? So to add or subtract fractions or rational expressions, which are fractions, right? With the same denominator, combine the numerators and place that result over the common denominator. Always trying to simplify your answer by factoring top and bottom and canceling out any common factors, okay? So right here it says perform the indicated operation. So we're adding. And in order for us to add fractions at all, our denominators have to be the same, right? That's just a rule, right? You can't add 1/4 and 1/2 and say it's 2/6, right? We can't do that. That's breaking the rules. We have to find a common denominator. Well, these already have the same denominator. So we are just going to look at, right? These are already written over the same thing. So we're looking at this part. We're looking at 7x minus 1 plus 4x minus 3. And we are going to work on that numerator, okay? Well, we're just going to add like terms, right? There's a 7x and 4x, -1 and a -3. Okay, so we have 11x minus 4 over our common denominator that was already there, 3x plus 2. Okay, and that's it. So we're just combining that numerator and putting it over our common denominator, right? So this one has a common denominator of x squared minus y squared, okay? X squared minus y squared is the difference of two squares, correct? Right, we can write these like this. Still the same thing. Okay, but we're going to factor them if we can. All right, so we're going to put this over x plus y, x minus y. Now, just look at that numerator. So we have 5x minus y minus, okay, minus, and we're going to keep it in parentheses, 4x minus 2y. Okay, so what needs to happen here when it's a subtraction problem, we're not going to forget to distribute our negative to both terms, okay? Right, so when it's a subtraction problem, we are going to have to distribute that negative through. Now we can add like terms. 5x minus 4x, and then negative y plus 2y. So that gave us x, 1x or x, plus y over x plus y, x minus y, okay? Then we have x plus y over x plus y, which is 1. So we can cross those out. So our answer is 1 over x minus y. Okay, so that's why at the beginning we factor everything, because we want this to be all the way simplified, right? And if we would have never changed this to this, we would have never been able to cross out, okay? So that was with like denominators. What if they are different though? Because not all fractions have the same common denominator right off the bat, right? So, and when we add and subtract fractions, we have to have that common denominator, okay? So here's how you find the least common denominator. You're going to factor each denominator completely. So make sure it's factored. Then you're going to list the factors of the first denominator and then add to that list from the other denominators that are not in that list. So look, when you're making your list, you need to have everything in your denominators accounted for one time. Okay? Everything needs to be accounted for one time. All right? So for this one, let's skip to this one. Okay, so for this one, we're going to factor each denominator, okay? X squared minus 2x minus 15. X and X, our signs are different. And then factors of 15, that'll add to give us -2, are 5 and 3. Okay. Factor the other one. That's the difference of two squares. Okay. Now, your least common denominator. I'm just going to do it over here. You're going to go to your first fraction and you're going to write each one that you have. Okay. In our first denominator, we have x plus 3 and x minus 5. Go to your other one and write down over here anything you have new. Okay. We have x minus 5 already, so we're not going to write it. We do not have x plus 5. Okay. Like I said, everything in your denominator needs to be accounted for one time. Okay. So this would be your least common denominator. Well, there we go. All right. So once we find the least common denominator, you're going to multiply the numerator and denominator by any factors needed to make the least common denominator, add or subtract the numerators, and simplify. Okay, so that looks very, very complicated. It is not. Okay, I'm going to show you what I mean. Right, so here we're adding. So let's look at some examples of these. All right, so for this one's a little different than the one we did. Okay, you need everything accounted for, right? Well, if I have a 3x and a 9x squared, if I say that my least common denominator is 9x squared, and I told you, I said that everything needs to be accounted for one time. Well, 3 is in here, and so is x. Okay, so if I multiplied the top and the bottom, right, I need to make this denominator say 9x squared. The way I'm going to do that is multiply by 3x on the top and the bottom, right? That's how I make that say 9x squared. Over here, I don't have to multiply anything because it already says 9x squared, right? Okay, so I would get 15x over 9x squared plus 2x plus 1 over 9x squared. Okay. Once you have them the same, your denominators, you're just looking at your numerator. You're going to push it together and put it over your common denominator. Okay. Add like terms. Okay, and you're done. Okay, so this one was a little different because it was just numbers and it was just a monomial, so one term and one term. Okay, and we weren't adding anything, right? So we just made this term look like this one. They also can look like this. Okay. Everything needs to be accounted for one time. So we have an x minus 2 and an x minus 3. Now, we need both denominators to say x minus 2, x minus 3. So whatever is missing in either one, that's what you multiply the top and bottom by. Okay, so for this one, we're missing x minus 3 here, right? So we're going to do top and bottom. Over here, x minus 3 is missing x minus 2. So we do top and bottom. Now that they both say the same thing, we can put them all over one fraction, all under that least common denominator. Now we're going to look here. Okay, 8 times x minus 3 minus 2x times x minus 2. Okay. And then you just clean up that numerator. Okay, so we're going to distribute. So we get 8x minus 24 minus 2x squared plus 4x all over x minus 2, x minus 3. So let's keep cleaning up. Let's add like terms. So negative 2x squared plus 12x minus 24 all over our denominator. And we can clean up that a little bit more. Okay, we can take out a negative 2 and get x squared minus 6x minus 12 or plus 12. Okay, so we took out a negative 2 from our numerator, right? So that means all of our signs had to change. Okay. This is an easy trinomial. So let's factor that. Our signs are the same in both negative and factors of 12 that add to give us negative 6 are non-existent, right? Don't exist. Oh. Right? Nothing. For 12, we have 1 and 12, 2 and 6, 3 and 4, right? We can't add any of those together and get 6 in the middle. So this is our answer. If we could have factored that and gotten an x minus 2 or an x minus 3, then we would have crossed out. Okay, so I was just checking to make sure we didn't have any of that. Okay. Let's do 2 more. So for this, we need to factor these guys right? That's the difference of two squares. Okay, now everything needs to be accounted for one time. So you go to your first fraction and write those down. Okay, in the other fraction, the only new one is x plus 2. Okay, if you look at this list, it should cover every single thing in your denominator. Okay, now you need both fractions to say this purple line. So whatever is not there, we're going to multiply it and put it there. Okay, so this has x minus 3 and x plus 3. It is missing x plus 2. Top and bottom, remember? X plus 2, x minus 3. This is missing x plus 3. Okay. Now, they all say the same thing on the bottom, so we write them over one term. It doesn't matter which order you write these in because we're multiplying. Okay. Then we look at the top. 6 times x plus 2 minus 5 times x plus 3. So we're going to clean up. Okay. 5x minus 5x minus 15 over that denominator. Add our like terms. So we get x minus 3 over x plus 3, x minus 3, x plus 2. Okay, look at the bottom and the top. Make sure we can't cross out. We can. X minus 3 and x minus 3. So we get 1 over, right, because that's all that's left. X plus 3, x plus 2. Okay. One more. This one has 3 fractions, okay? But let's look what happens. We can factor this guy. It's the difference of two squares. Okay. We still need everything accounted for. In our first fraction, we have x plus y, x minus y. Okay. And then we have x plus y, we already have it. X minus y, we already have it. Okay, so your least common denominator is x plus y, x minus y. So now we're gonna go and we're gonna look, and we need every fraction to say x plus y, x minus y on the bottom. Okay, and if it doesn't, that's what we're gonna multiply by. Right? The first one, we're good. It says x plus y, x minus y, so we don't need to multiply by anything. This one needs an x minus y. This one needs an x plus y. Okay. Now that they all say that, we're just looking here. So, whoops. So you have x plus y, x minus y. And then 2x plus 1 times x minus y minus 1 x plus y. Okay, now we're going to clean up. 2x plus x minus y minus x minus y. All I did was distribute plus x minus y minus x minus y over that common denominator. we have an x and an x and an x. Okay, well, x minus x is 0, so we're left with 2x. Minus y is minus 2y. So we're left with 2x minus 2y over our common denominator. Okay, we can take out a 2. And look what happens. We have an x minus y on top and on bottom, so we can cross out 2 over x plus y is our answer. Okay, so that is how we do addition and subtraction with rational expressions. It's all about finding that least common denominator, and that is making everything, like everything in our denominator needs to be accounted for one time, and then we go and we fill in. Okay, so if it's missing in one denominator, we need to make it say the same thing, so we multiply top and bottom by whatever. Then we're going to circle that numerator and only focus on our numerator and just clean it up and factor if we can and cross out if we can.